Here's another stoichiometry problem, but this one does not involve theoretical yield limiting reactants. Again, we're given the chemical reaction in word form, so we have to translate things like hydrochloric acid is HCl, and we're dissolving iron, Fe, and we're making iron 2 chloride. So again, do your crisscross, and you should come up with the formula FeCl subscript 2, and the other product is hydrogen gas. So this is almost balanced. We just need a coefficient of 2 in front of the hydrochloric acid, and that should have everything balanced. Now in this problem, we want to dissolve a certain amount of iron, 2.8 grams of iron. How many grams of hydrochloric acid do we need? So we are relating these two chemicals together, two reactants. We're not trying to turn the reactants into products in this case. We don't care how much, for example, hydrogen gas we're going to make. We just want to know how much hydrochloric acid. The nice thing about stoichiometry is it relates any two chemicals together. Once you have the balanced chemical equation, the coefficients let you relate any two chemicals, whether they're two reactants, two products, one reactant, and one product, it doesn't matter. So the unknown, how many grams of HCl do we need to react with 2.8 grams of iron? So if we want to relate these two together, we have to make sure we get the correct unit of moles. So grams of iron, turn that into moles of iron. And the molar mass of iron from the periodic table, 55.85. Then moles of iron, we want to turn that into moles of HCl. And our mole to mole ratio, it's 1 mole of iron reacts with 2 moles of hydrochloric acid. And then turn those moles into grams using the molar mass. And that is an answer of 3.7 grams of HCl. So for the first part of this problem, how many grams of hydrochloric acid do we need? It wasn't the typical format that we've seen in the previous problems, which was turn your reactants into products. But the steps are very, very similar. Now the second half of this problem is back to how many grams of the product would we make? So we found the grams of hydrochloric acid that would react completely with the iron, and both of them are going to run out at exactly the same time. So in this second problem, we could start from the 2.8 grams of iron, or we could start from 3.7 grams of HCl. Both of those would give us exactly the same answer for the amount of H2. So I'm going to start by saying how many grams of hydrogen could come from 2.8 grams of iron. Step 1, turn my grams into moles using the molar mass. Then once I have moles of iron, I want to turn that into moles of hydrogen, and I look at the equation. Iron to hydrogen is a 1-to-1 ratio. And then once I have moles of hydrogen, I can turn that into grams of hydrogen using its molar mass of 2.02. So I get an answer of 0.10 grams of hydrogen. try this one. How many grams of hydrogen could have come from the other reactant? 3.7 grams of HCl. If you work through this, you're going to have very similar steps that we just had, but obviously molar masses will be different, and you will get the same answer, 0.1 grams of hydrogen. Next, what happens if someone accidentally used 10 times too much acid? How would that change the amount of hydrogen gas? So we calculated we were supposed to add 3.7 grams of hydrochloric acid. What would happen in the lab if we used 37 grams? So with 3.7, we had the perfect amount of each reactant. You could say both of them are limiting because both of them run out at exactly the same time. This problem says we use 10 times too much. 10 times too much, so 37 grams of hydrochloric acid, only the first 3.7 grams will react because we only have that much iron to react with it. Once we use up the first 3.7 grams of hydrochloric acid, the reaction is stopped. There's no more iron, which would be our limiting reactant, so we would make exactly the same amount because we've used up the limiting reactant, and that stops the chemical reaction.